For my CSE496 ethical hacking course at Brack University. In this video, I will be presenting the solution of the second challenge with the title New Caesar. Let's get started. So where's the challenge? In this challenge, they have said that we have found a brand new type of encryption. Can we break the secret code? And they have given us a code. And then they have told us to wrap the flag with CTF. That means they have told us to submit in CTF flag format. And they have given us a Python file. Let's go ahead and download the file. I have already downloaded the file. I'm in my downloads directory. If I type ls, I can see that file. If I type cat and the name of the file, I can see what's inside the file. But before I go ahead and explain what this file contains, let's just try to understand it. So this file contains an encryption algorithm in which they have taken a plain text, then they have done encoding, which is a base 16 encoding. It is a different one. Then they have done a shift operation, and finally we can get a ciphertext from this code. So now let's go ahead and see what's in the file. So the very first line, they have imported string. They have taken lowercase offset ordinal value of a, and they have taken a variable alphabet in which they have kept the first 16 letters of English alphabet, and in flag they have kept a string, in key another string. And in this line, if we see that for k in key, k in alphabet, that means the each letter of the key needs to be within the alphabet string. That means within the first 16 letters. And the next line says assert length of key equals 1. That means they have fixed the length of the key to 1 letter. That means if the key, like here, the key is more than 1 letter, so it will show us an assertion error. We can check it out. Like if we try to run the Python and the code, which is New Caesar, and yes, we have gotten assertion error because of the first one here. The flag contains letters beyond the 16 letters. And then they have taken flag as an input to the B16 encode function, and the output is in B16 variable. So in this function, what it does is, for it accepts the text of the flag, and a for loop has been run here throughout that plain text. And for each letter, it is at first converted into a binary format of 8-bit, and then it has been divided into 4 bits and 4 bits. Basically, it has been divided into 2 pairs, and it has been converted into an integer. And finally, the integer has been used as an index to retrieve a letter from the 16 letters. And then finally, the string has been returned. And after that, another for loop has been run throughout this B16 string, in which they have performed a shift operation with the help of shift function. And if we see the shift function here, so they have actually added the two values, which is they have accepted the C as the text and key, and they have done a modulus operation so that the alphabet remains within the bound of 16 letters. And then finally they have printed the encrypted letter. So if we want to decrypt it, we'll have to keep in mind that the key is any one letter among first 16 letters, and then we'll take the cipher text and we will do a backshift operation at first, like they have done a shift at the last, but we'll do a backshift at first, then we'll decode that and we can get the plain text. So this is the code that I have written. This part remains the same. The function of shift we've just modified here, where instead of adding we've just subtracted to do a backshift. And within this encrypted text we have kept the text as an input. Then for K in key in alphabet, that means we are doing a brute force to find the key. We are taking one letter from the alphabet at a time, and then we have run a loop, a for loop throughout this string of encrypted text, and we call the backshift function to backshift it. Then we have called the base 16 decode function, and what it have done is just at first taken one letter and the letters beside it, which is J and J plus 1, and then tried to find the index from the alphabet string, then converted into a binary format of 4-bit, and we have kept that to a binary 1 string, then another one is binary 2 string, and finally we have add those two 4 bits binary string to 8-bit string, and we converted that to a integer, and finally we have converted the integer to a character, and we have returned the value. So that's, and then we just printed the text. But we have to keep in mind that we'll get a decrypted text for all the keys here, because these will be 16 outputs, because we don't know what is the key here. So we have printed these lines just to distinguish one output from another. Let's go ahead and run this code and see what we can get. So at first I will go to my code directory and I will type ls, and yes, here we can see the decryption code. We'll just run this code, Python and name of the file. Yes, we can see all the outputs. If we just pay attention to each of the output, we can see that only this one seems to be a flag, and we'll copy that and paste it here, and we can see that this is actually the flag. So this is the solution. Thank you everyone.